Okay, I'm gonna try something different here. I made the video for this and then I deleted it, but my pen strokes obviously are saved. And so I'm gonna try to talk about this with my pen strokes already done and just kind of highlight things in red pen. So determine the end behavior as x goes to infinity or negative infinity. What does that mean? First of all, end behavior. That would be, for example, on this function, the end behavior is as x goes to infinity, what's happening to this function out here? As x goes to negative infinity, what's happening down here? Here it's obviously going to infinity, and here it's going to negative infinity. But it doesn't have to. It could do this. And if this is a line here at 2, it's called an asymptote. The end behavior as x goes to infinity could be getting closer and closer to 2. Okay, so let's go ahead and look at these. As x goes to negative infinity of x to the 7th, plug in big negative numbers. We're talking hundreds of thousands, millions, and so forth. A negative number to the 7th power is going to be negative a big number. Same thing as a positive number to the 7th is going to be positive infinity. B. As x goes to infinity of this guy, well, remember as x goes to infinity, x is huge. These numbers right here are really inconsequential compared to a million to the 4th, a billion to the 4th power. So this is the same as x goes to infinity of negative 12x to the 4th. So plug in a big positive number. X to the 4th is positive times negative 12 is a negative infinity. Same thing for negative infinity. These don't matter. Negative 12 down here times a positive number, because negative big number to the 4th is positive, times negative is still negative infinity. C. X to the negative 4th, oops, right up here, is 1 over x to the 4th. So as x gets huge, 1 over a huge number is 0. Gets closer and closer to 0, the limit 0. Same thing here. Negative infinity to the 4th is a huge positive number. 1 over a huge positive number, as it gets bigger and bigger and bigger, it gets closer and closer to 0. And then lastly on D, right here, we know that as x goes to infinity or negative infinity, oops, I think I did negative infinity here, yeah. As x goes to negative infinity, these guys don't really matter, right? But instead of just knocking them off, which is okay to do, I want to look at it algebraically, and this is really why this happens. If I multiply top and bottom by 1 over x to the 3rd, x to the 3rd is the highest power of x. Look what happens. And I got to distribute it. I get 6 minus 5 over x plus 2 over x cubed. In the denominator, I get x cubed over x cubed is 1 minus 8 over x cubed. Now as x gets huge, negative infinity, these numbers all get closer and closer to 0, don't they? Make sure that makes sense. 5 over a negative 100, 5 over a negative 1,000, 5 over negative 10,000. Those are all getting closer and closer to 0, so the quotient is getting closer to 6 over 1. Okay? All right. Hope that works for you.